Welcome to another awesome edition of Common Algebra. This video is for Algebra 1, Chapter 7, Section 1, Graphing Systems of Equations. Alright, so far your work in algebra has been limited to working with one equation with one letter or one variable in it. So now in this chapter you're going to learn how to deal with when you have two equations and two variables, and you're going to be able to solve for both of them. Any ordered pair that makes both of the equations true is a solution to the system. And you can write your answer in an ordered pair like this, x, y. For instance, the answer might be 1, 4. Later on, we're going to learn how to solve equations that have 3 letters in them, like an x, y, and a z. And even we'll go to 4 equations with 4 variables. But that's something for you to look forward to. So let's just start with an example that asks you to determine whether the ordered pair is a solution or is not a solution. So here's what a system of equations look like. You have two equations with 2 variables. And remember, they go together. The answers you find have to work for both of them. So part A is asking you, is this a solution? And we always go alphabetical. Like if these equations had A's and B's in them, the 3 would be the A and the -1 would be the B. In this case, we have x and y, so we know they're asking you, in this system, is x equal to 3 and y equal -1? Is it a solution? So the only way to do that is to plug them in and try them. So I took the first equation and I put 3 in for x right here, and I put -1 in for y here, and now let's do the math. 15 plus 2, is that equal to 8? And obviously not. So since it didn't work for the first equation, we don't have to go any further. We can say no, this is not a solution to this system. So now let's try this xy as a possible solution to both of them. So plug in the 2 for x and the 1 for y. So in this first solution, 10 minus 2, oh, it does work. 8 equals 8. But remember, it can't just work for one, it has to work for both. So putting in the 2 for the x in the second equation and the 1 for y, does this equal 4? And indeed it does. So we can say yes. 2, 1 is a solution for this system. So to repeat, if you're asked if this is a solution, plug in the 2 values and see if it works for both equations. Now let's learn how to solve these when you're given 2 equations with 2 variables and you don't know what the solution is. The first method we're going to use is called the graphing method. So to solve by graphing, you need to graph both equations on the same plane and see where they cross each other. The point of intersection is the answer. And then after you find the answer, you should check it by plugging it into both equations. The reason that the intersection is the answer is because that point right where they cross each other, like if this line is cruising along here and this one along here, right here where they cross, this xy makes both of them true at the same time. So I hope that makes sense to you why the intersection is the answer that we're looking for. So the first example we have, we're asked to solve this system by graphing. So we're going to plot each line very carefully, and we're going to see where they cross. Now, whether you're doing the T-chart method or the calculator method, you do need to solve both of these for y. So y here equals -x plus 5. And for this one, we get -3y equals -x minus 3. And then if we divide everything by -3, we get y equals 1/3 x plus 1. Okay, now let's graph these using the slope-intercept method. This first one crosses the y at 5. I'm going to put the y-intercept in. And then the slope is -1. So it's down 1 and over 1, down 1 and over 1, and so on. And then I got to connect those dots. Now let's graph the second one. The y-intercept here is a +1, so I'll put the y-intercept. And the slope is up 1 and over 3, up 1 and over 3. And we need to connect those dots. And we can see that these lines do indeed intersect. So this point right here is what I'm looking for. That point makes both of these true at the same time. And this ordered pair happens to be over 3 and up 2. So that means that the x is 3 and the y is 2. And you could write your answer like this, or you could put it like an ordered pair, and either way is fine. Now in class we'll discuss a little further how to, if you entered this on the first entry in your calculator, and the first y equals, and you entered this on the second y equals, and then this graph appeared on your calc screen, there's a key where you can ask the calculator to find the intersection for you. So we'll discuss this calculator work in class. The next thing I want to talk about is that you have to realize there's 3 possible things that could happen when you graph 2 lines. The first possibility is like the example we just looked at, where the lines intersect each other at one point. And they can be absolutely anywhere in your graph, let's say here and maybe right here. And this is their point of intersection, and that's the answer. And when that happens, we know we have found one solution, and it's where they cross. Another thing that could happen is that the lines coincide, and this word, what this means is that it's the same line. One line is graphed right on top of the other. So it's possible that the equations look a little different, but if you graphed this line and then you graphed the next equation, I'll try to make it look like they're right. Wow, try that again. So I tried to make it look like one line is right on top of the other. And when that happens, there's infinitely many points on that line because the line is the solution. And the other possible thing that could happen when you graph your 2 lines, they could run side by side forever and never cross. And when they never cross, then there is no solution. So we need to be aware when we do this entire chapter that these 3 possibilities exist: of one answer, a whole bunch of answers when one line is on top of the other, or no answer at all. All right, so now you have the knowledge you need for section 7.1. So have fun graphing those equations.